Hello and welcome to our short video today. My name is Matthias Beer. I'm a product manager for oscilloscopes at Rohde and Schwarz. Today we would like to measure a radar signal which includes an up and a down chirp. We want to measure this in time and in frequency domain. As signal source we use a vector signal generator SMBV which playbacks the radar signal, and this radar signal includes alternating up and down chirp. We see on the oscilloscope, this is a high performance oscilloscope, RTP, already the pulse, the radar pulse. And now in order to make the chirp, the up and down chirp visible, we use a measurement function. For that we go into the measurement menu, select the time interval error measurement. We enable this measurement, and in order to see the variation over time, we enable also the track. To limit the measurement to the pulse and not to the pulse off time, we use the gate, and the gate starts at 0 seconds, which corresponds to the trigger point, and goes up to the end until the end of the pulse, which is 25 microseconds. So let's have a look at the result. We see here on the red curve, let me move this a little bit. We see here the time interval error, the changes, the track versus time, and the 0 line corresponds to the center frequency of our pulse, which is 5.25 gigahertz, and the variation shows the up and the down chirp which is implemented in this pulse. So this is the analysis of this radar signal in time domain. Now we will do the same in frequency domain. For that, I limit the time domain measurement, I get back my pulse, and I enable the spectrum measurement. I do this in our toolbar. This is this part here at the upper part of the screen. I press the FFT button, and what I do, I select a center frequency of 5.25 gigahertz and a span where I want to do the measurement of, let's say, 20 megahertz. As resolution bandwidth, we use, for example, 1 megahertz, and to limit the FFT to the pulse duration, I simply can draw a rectangular frame, and then the FFT is gated and is applied to this area. Now this is the FFT spectrum of our radar pulse. The next thing, to make the changes versus time visible, we simply enable the spectrogram. We do this in the FFT setup menu. Here we have 3 columns. The first 2 columns are corresponding to basic spectrum analyzer settings like start and stop frequency, center and span, but it includes also the resolution bandwidth. And in the 3rd column we can enable the spectrogram, which we do now. Then we minimize this, and what we see here in the spectrogram is the change, the chirp, the up and down chirp of the signal. So this video showed a short measurement of a radar pulse signal which includes an up and down chirp. We analyzed this in time domain and in frequency domain. We used the tie function in the time domain measurement and the FFT and mainly the spectrogram display in frequency domain. I hope this video was interesting for you, and I would like to say thank you for watching, and I'm looking forward to see you the next time. Bye bye.